Okay, so we're going to have a look at how we could find the equations of tangents through a point to a circle. So what we're going to do first is we are going to write down the general formula for the equation of a circle, which is y minus y1 equals m on x minus x1. And essentially this is what we're looking for. We're looking for the equation of a tangent. Tangent is just a line, and this is the formula for the equation of a line. You need two things for this formula. You need a slope and a point. We have the point x1, y1, so we're going to sub this into the formula, but we don't have the slope, and essentially that's what the question is going to be. So y minus y1 is 0 equals m, the unknown slope, on x minus the x coordinate, which is 1. I'm going to multiply this out, so I get y equals mx minus m, and we may use the line in this format, but more than likely we're going to need it with the x coordinate first. Then we have, or the x coefficient first, then we're going to have minus y minus m equals 0. So this is the equation of a line, but we just don't know what the slopes are. If we're to visualize this, we have a circle here, and it's easy to get the center. The center is half the x coefficient, 6, and half the y coefficient, 5, and obviously we change the signs there as well. So this center of the circle is 6, 5. And then the point 1, 0 is obviously lower than this and to the left. So there's a point down here, 1, 0. And from this point 1, 0, we have two tangents going to this circle. So maybe they look something like this. Now the key to this question is that the perpendicular distance from the tangents to the center of the circle is equal to the radius. Let's put 6, 5 up here. So there's the perpendicular distances, and they're equal. They need to be equal to the radius. Now what is the radius? Well, the radius of this circle is the square root of g squared plus f squared minus c. So the radius is, now g squared is 6 squared, which is 36, f squared is 5 squared, which is 25, minus 51. So this is nice and handy. This is going to be 36, and 25 is 61 minus 51 is 10. So the radius is root 10. So this is root 10 and this is root 10. So we have all the pieces now. So the perpendicular distance from the center of the circle 6, 5 to these lines mx minus y minus m equals 0 is equal to root 10. So let's line it up. Let's write down the formula for the perpendicular distance. So the distance is equal to the modulus of ax1 plus by1 plus c over the root of a squared plus b squared. Now, d is the perpendicular distance, which we know is equal to the radius, root 10. A is the x coefficient of the equation of line, which is m. B is the y coefficient, which is minus 1. And c is the constant, which is minus m. And we also have our x1, y1, which is the point, the center of the circle, 6, 5. So 6, 5 is x1, y1. So we have all our pieces, so we're just going to sub them in and solve the equation. So we have the modulus of a, which is m, times x1, which is 6, plus b, which is minus 1, by y1, which is 5, and plus c, which is minus m, over the square root of m squared plus minus 1 squared. The perpendicular distance from the center to the equation line is equal to the radius, which is root 10. So in the modulus I have 6m minus 5 minus m. I'm going to multiply up by this root of m squared plus 1. So I get the root of m squared plus 1 times root 10, which is 10m squared plus 10. So I kind of took a small shortcut there. But if you have root 10 by the root of m squared plus 1, the rule of thirds says we can join those to say 10m squared plus 10. We multiply what's underneath the thirds. Okay, so this is the modulus of 6m minus m is 5m minus 5, which is equal to the root of 10m squared plus 10. Now with a modulus equation, I'd normally let it equal to plus or minus whatever was on the other side, but because we have a square root here, the best thing that we could do is square both sides. So I'm going to square the left and square the right. If I square the left, it's like squaring a bracket. So I have square the first 25m squared, twice the product, which is minus 50m, square the last, which is 25, and then square the square root, we have 10m squared plus 10. So it removes the third. Bring everything to one side, we have 15m squared minus 50m plus 15 equals 0. I'm going to divide across by 5 just to make the factorizing a little easier. So I have 3m squared minus 10m plus 3 equals 0. Two sets of brackets. And I have 3m and m, 3, 1. They're both minuses. So I have 3m equals 1, which is m equals 1 over 3, and m equals 3. So my two slopes, if I go back up to my sketch, so this slope was a third. Now I've drawn it a little horizontal, but the sketch is only just to get an idea. And then this slope is 3. And so to finish the question isn't to find the two slopes, though we do need that. The question is, what are the equations of the tangents? So if I sub in the slopes one at a time, one of the tangents is a third x minus y minus 1/3 equals 0. If you want to multiply this by 3, just to get x minus 3y minus 1 equals 0, you can. So that's one tangent without the fractions. I mean, you can leave it like this, though, with the fractions. And then the second answer is where we sub in 3, so we get 3x minus y minus 3 equals 0. So they're the equations of the two tangents. Okay, the hardest thing probably in that question is the idea that we need to create an equation of a line that has no slope in it, or an unknown slope. Okay, a lot of students might not come up with that step. Once you have that step, the idea that the distance from the center to the tangents is equal to the radius is a common train of thought when you're doing this type of a question. But coming up with that initial equation when it isn't given to you can be a little bit tricky. Okay, that's it.